Okay, so we're on part 3, we'll call it, of days 12 through 13. Okay, and this is just finishing up, kind of just looking at some more complicated problems. So first off, we've already talked about 2 of our properties of radicals. And so remember from a review from last Thursday, if you have the nth root of x, that's the same thing as x to the 1 over n. If you have the nth root of x to the m, that is equal to x to the m over n. I don't remember if those were the exact variables we used, but the other 2 that I want to review with you from that you've learned before in Algebra 1 is called your product property and your quotient property, okay? So we can just do this off to the side. So your product property of radicals tells us if we have the nth root of a times b. So notice a times b, they are not like bases. That is the same thing as the nth root of a times the nth root of b. And you can go both directions with that, okay? So notice how you can multiply what's underneath just as long as the indexes are the same. And then quotient property is the same thing. So if we have the nth root of a divided by b, I meant for that to be an n, just to keep it consistent, that is the same thing as the nth root of a divided by the nth root of b. Okay, so again, you can go both directions. So when you look here at this question, number 13, it says, can the square root of a times the cube root of b be simplified? Refer to the properties of exponents to support your answer. So like right now, those indexes are not the same, right? So if you look at this, you can't just say, oh yeah, it's the square root of AB or the cube root of AB, because they're not the same indexes. So the only way we can work through that is you have to write that as a to the 1/2 times b to the 1/3. Now, those still aren't like bases, right? So you can't add your exponents. So our answer is no. There is nothing left to do. You can write it like this, or you can write it like that, but there's no way to combine those under the same radical. There's no way to write those with the same exponent, okay? So in 14, it says use the properties of exponents to prove that that is true. So right here in 14, we're proving that that product property that I just reviewed with you is true. The way you can do that is we can write, it's probably easier to show working with the right side. This is the same thing as AB to the 1 over nth power, right? And when you think about that, that is a times b. So this is the same thing as a to the 1/n times b to the 1/n. And the only reason you can distribute that exponent through is because it's multiplication and not addition. And then you get the nth root of a times the nth root of b. All right, so flip this over. We're going to look at some more difficult problems here. There is one worked out. Okay, let's just look at that first. So first things first is notice that these are the same indexes. That is something to cheer about because you don't have to go through and break each thing down to then multiply. You can just multiply what's underneath. 9 times 3, 27. X to the 2nd times x to the 4th is x to the 6th. Y to the 8th times y to the 2nd is y to the 10th. And then at that point, you can do the cube root of 27 because this is the same thing as this, and this. Or you can even write it as 27 to the 1/3, x to the 6/3, y to the 10/3. Okay? The cube root of 27 is 3. 6 divided by 3 is 2. 10 divided by 3, there's nothing you can do with it. Okay? Okay, if you feel you can do any of these on your own, I would say pause it, try it. Okay? and see how you do as I go through it with explanation. I mean, that's the best way for you to try some of these. So let's look at question 15. Actually, let's read the directions. For 15 through 17, it says leave any negative exponents as they are. So that means if you get a negative exponent, leave it negative. For 18 through 22, no negative exponents. Okay, so that means if you have a negative in the numerator, you need to move it to the denominator. If you have it in the denominator, move it to the numerator. Okay, so let's just start here. We have this entire thing being raised to the 2/3 power. So, and then, hold on, simplify the... Okay, I think we are just simplifying with exponents, so leaving them in rational exponent form. So, here, remember, this is the same thing as 27 to the 2/3 power times x to the 9th to the 2/3 power. So 27 to the 2/3, you may be thinking, what do I do first? Could you just type it into your calculator? Absolutely, but remember what this is. This is the cube root of 27, and that squared is right there. You can think of this as cube root of 27 times 27, right? What is the cube root of 27? It's 3. Now, what's 3 squared? 9. So no matter how you got there, you could, yes, you could plug that right into your calculator and you'd get 9. But you should be able to understand that, okay? Do your cube root of 27 first, then square it. Could you square the 27 first and then take the cube root? Yes, but the square root of 27 is not something you would recognize, but you could still do it, okay? That order doesn't matter. Now over here, you have power to a power. So we're going to do x to the 9 times 2/3, which gives us x to the 6th, and that would be our answer. Okay. 16, we have a quotient. So I'm just going to distribute it through to both. And remember, we don't want to just necessarily rely on our calculators. SAT, you don't have it the whole time, okay? So this is the same thing as the 4th root of 16 cubed. This is the 4th root of 81 cubed. So what do you want to do first? I always suggest, especially if you're not working with a calculator, do what makes the number smaller first. The 4th root of 16, you can do. Okay, that is 2, because 2 times 2 times 2 times 2 is 16. The 4th root of 81, you can do, because 3 times 3 times 3 times 3 is 81. So all we did is we took care of the 4th root of 16, and we took care of the 4th root of 81. And now you can cube the 2, and you can cube the 3, and you get 8 over 27. All right, 17. The only ones you can combine are your like bases. So your x, actually I'll do that with a highlighter instead. Your x's, you have x to the 1st over x to the 1/3. And then you have your y's. Y to the 3/2 divided by y to the 1st. No matter what, we're moving everything up. We don't care if there's negative exponents. Remember, that's what the direction said. So to divide like bases, you subtract your exponents. To divide like bases, you subtract your exponents. And then just simplify. 1 minus 1/3 is 2/3. 3/2 minus 1 is 1/2. And that would be your simplified answer. And notice for that, positive exponents anyways. Okay, let's look. 18. So 18, we don't want negative exponents. Do not start changing them right away. Let's see what happens when we multiply first, okay? Our product rule with exponents, we can just distribute that -2 to both. So that's the same thing as x to the -6 to the -2 times y to the 8th to the -2. You do not need to write that step, okay? But just so you, in case you don't know why I'm doing what I'm doing, There's the explanation. You can only do that because it's a product and there's no plus or minus. So now, power to a power, you have a negative exponent. We do not want that there, okay? The only one that's getting changed is the one that's being taken to a negative exponent. It's just the y. Do not move anything else. So that's going to go down to the denominator and become positive. That's your answer. That's all you can do. Those are not like bases, nothing else. All right, number 19. You can do a few things here. First of all, if you did try converting these to exponential form, or not exponent, yes, rational exponent form, you would get 6 to the 1/5 times 24 to the 1/5 all over 4 to the 1/5 times 9 to the 1/5. We don't have anything to help us do that, right? Because the bases aren't the same. So that is not the route we want to take. But what we do know is that if our indexes are the same, you can multiply and divide what's underneath the radical. So this is just going to turn into the 5th root of 6 times 24 all over the 5th root of 4 times 9. Okay? And for these, you guys, you cannot just be jumping to answers. You got to show your work. So when we do this, we get 6 times 24 all over the 5th root of 9 times 4. And the other nice thing about our rules of radicals, we can write this as 144 over 36. Guess what? That's going to reduce down to 4. Okay? And since we did want this in exponent or rational exponent form, this is the same thing as 4 to the 1/5 power. Okay? And you can go through and type all that in and check that it is truly 4 to the 1/5. Okay, 21 and 22. All right, so looking at 21, you have no power outside, so that's great news. So all we need to do is multiply our like bases. So like bases, first of all, your numbers, okay? Your next set of like bases are your x's. Your next set of like bases are your y's. Okay, we don't want to start moving exponents around yet because maybe when we multiply them, negatives become positives, so we want to first do the multiplication part first, and then let's see what's negative, okay? So when I multiply this, we get negative 12. Then, when I multiply my x's, 1 plus negative 3, that leaves me with x to the negative second. When we multiply our y's, negative 2 plus 5 gives me 3. The only thing that gets moved to the denominator is the terms that have a negative exponent. That is it. Do not move that negative 12. Do not move that y cubed. The x to the second is the only thing that goes to the denominator because that is the only term that has a negative exponent. Please, please, please do not move anything else. Your answer is negative 12 y cubed all over x squared. All right, next one, they do not have the same index. So what do we have to do? Remember what index, that's the 4 and the 3 right here. These are not the same. You cannot do anything yet, okay? So first step is convert to exponent form. Since these are the same base, we can combine them by adding our exponents. You are going to add 3/4 plus 4/3. And when you do that, you get 25 over 12, which is positive, and you can leave it alone. Okay?